everyone, welcome back to my channel EduVibe. In today's lesson, we are moving to the next topic of the atomic physics, which is the activity and the half-life. This is very easy topic and it's easy to understand this topic. It is half-life first. So activity, to doing something. The rate of decay of specific nucleus is unpredictable. We can't say that specific nucleus have which type of rate of decay. It's unpredictable. Maybe they decays in a moment, in a few minutes, in a few hours, or a few years, few thousand years. We don't know that thing. However, if you have a large sample of the probability and statistics work backward for large samples, but we can much have a more accurate prediction of how many nuclei will decay in the given time. So this is the all thing that how many nuclei will decay in a given time. That if you have some given time, how many nuclei can be done? Because this has the more like there's a time. So for this, we can have an activity which notify the capital A or decayed rate of sample is the number of nuclei in a sample that decay within a given time. Number of nuclei in a sample that decay done in within a given time. That is what activity they do. That how much they do, how much they take time to complete that number of nuclei in a sample. The unit of the activity is the BQ, which is the equivalent decays per second. The radioactivity of the substance is the rate of the radioactive emissions, alpha, beta, and gamma radiations. All substance is the rate of radioactive emissions with alpha, beta, and the gamma. That's the thing. That's all the small theory you have to do, but in contact the theory questions from here, you get the more likely uh, the calculation questions. What is half-life? Half-life of an element Half-life of an element is the time required for half of it to spontaneously. That how half-life means is the time required for the half. That what time required for half or half it made is spontaneously transmuted. Another way of phrasing is that it represents the amount of time for an substance to decay to its half its original amount. So half of its original amount, how much they take time to complete that half of original thing. Original thing, the half of the decayed take how much time? Half-life of radium 234 in 24 hours. Day 0 we have 100%, then we have 50%, then we have a 75 to 25%. So that's the all thing you have to follow. And half-life questions are very easy. We discussed that question now. So we have two equations to do this, and we have that equation in your formula sheet. But I think that this equation is not in your formula sheet, so you have to memorize this. So n is equal to n0 times 1 half raised to power n, and that n, if you don't have like you have t or t half, so you can find the n from here. So it's t divided by t half. So n is the mass, activity, or amount of time they take, and there is the initial thing, initial mass if you given as initial activity or amount. N is the time of the half-lives, that's how many half-lives they take, and the t is the lapsed time, the two type of times you get, and sometime you get this time too, which is the t half. T half means the half-life time. They've given us that. The units of the half-life equation are very flexible as long as all units are same, or the t1 to have the same units of the like seconds or hours. So it doesn't matter that you have to have a same units. If not, so you have to convert the one of them. So there's an easy thing, and we are straight to the examples of this. A J transfer may be the reduced to the detect the level of radioactive activity in units of the BQ. This unit is related to activity where one count detection on a dual counter represents a single decade. A sample of Xeon 137 has a half-life of 12 days. So they mentioned we have a half-life which is T half. They given us the T half and is found to emit beta negative particle at the rate of the 240 MBQ. Beta negative of this. So this is like initial thing given to you. You have to find the right decade equation for the Xeon 137 and the activity after 30 days. So you have to find the n. So firstly for A, you have to make the equation for that. So we have a zone 137 and we have 54 atomic number of this. This is a beta negative decade. So this plus you will get 137, 54 plus 1 is 55, and you have a CS in that thing. So this is a simple formula. For B, you have to find the N. So for N is equal to NO half N. But you don't directly have N. You have a T half, which is 12 days is given to you over there. You have NO, which is 240 MBQ. So you can find the N from here. So to find the N, you have T upon T half. What is T? This is the lapse time is given to you, so 30. So half time is 12. So this is the thing. So you can cut this if you want. So you get about like 10 divided by 4, which is again 5 by 2. So you can put these things over there now. So this is equal to 240 MBQ. This unit means the same. So you have like 30 days upon 12 days, which is the same units. And you will get a 5 by 2 when you cut this in simplest form. And when you solve this whole thing, you get about 42.426 MBQ, which is also like 42.43 this. So NO and N have to be the same units, and the time has the same unit. So that's how you can do this. So you get the answer of 42.4 MBQ. So this is the activity you can find. Easy questions. Sometimes you have to find the N. So we discuss those questions in the practice questions or the diploma questions when we're doing that. So small topic and we end that topic. So next topic is also very easy. We're doing the fission and fusion, which is then related to the radioactive equations you have to know for this. And we have some different setup of that. So yeah, this is all for this lesson, and we start doing the next topic in the next lesson. Learn with EduVibe, learn smart, not harder. Please like and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Take less creative with EduVibe.